Okay, we are almost up to the hour, so I will just begin. So, good morning, good evening, and good afternoon, wherever you are. My name is Paul Muchen, and I work for the ICANN's office of the CTO and the technical engagement specialist for the Middle East and Africa. And today, my presentation will be on improving the resiliency of the DNS infrastructure.
It's 13 hours.
So I'm going to speak about how this can be done using a new method. And this new method is what called Hyperlocal. However, before I actually begin to talk about Hyperlocal, I just want to give you at least a brief understanding of the DNS and the DNS root server system, what they are and why they are very, very important. So I will begin my discussion by talking about the root server system. So the root server system is as old as DNS, and DNS was first developed and deployed in 1983. The root server system actually followed in 1984, so immediately. So they're just as equally as old. Today, the root server system is widely distributed. There are over 1,000 instances. As of July 2020, there are 1,086 instances around the world. However, many people get to confuse them. They think there are only 13 root server instances or 13 root server systems. However, this is not true because what the 13 are actually labeled. So each root server has a label from A to M. So you have the a.rootservers.net and the m.rootservers.net. And each of these labels has their own individual IPv4 and IPv6 addresses. And in addition, there are 12 root server operators that actually manage a given label. We at ICANN manage one of these labels, which is the L root server. And so ICANN actually is in charge of actually deploying the L root system. So now that I've given you at least a big picture of what the root server system, I'd like to talk about how actually it's very critical, because the root server system forms actually the core of the DNS. And at the moment, there are at least 3 given ways that the root server system is deployed across the world. I will mention how these 3 are, and I'll also mention how Hyperlocal fits in as a 4th method. So one of the things that ICANN does, and this is the first method, is the root server system is actually done by shipping physical servers to actually an organization that's interested in hosting one. So let's just say you're a telecom operator in, say, Egypt, and you're interested in hosting an L-root server. You'll actually have to write to ICANN. And then after that, you'll sign a non-disclosure agreement with ICANN, and you'll go through some administrative and also some, some administrative procedures in order to procure a server. And once you get the server, then after that, you'll have to meet certain minimum specifications, such as having a network that can actually use any cast. And at the same time, you'll have to deploy the server in a data center. So one of the ways that I can actually summarize is that root servers are deployed by shipping a box to a premise, an actual physical data center, or a server room that is owned by an organization that's interested, and then it goes ahead and actually hosts the L root, and the L root is then configured and it goes live. That is one way. The other way that's being used is actually keep everything in-house. It's a closed way of doing things. So one of the root server operators, that is the US Department of Defense, through the ISP known as the Defense Information Systems Agency, DISA, that operates a G-root. They only have 6 instances, and they're only deployed in mainly military bases within different parts of the world. And 6 of these places are Columbus, Ohio, Honolulu, Hawaii, San Antonio, Texas, Stuttgart in Germany, Naples in Italy, and Fusa in Japan. So for theirs, it's totally closed, and it's only used within their own premises. Now, the third way is actually deploying in the public cloud. And this is a very interesting concept because there are two root server operators that have actually started to deploying their instances in the public cloud. And at the moment, only Cloudflare is what we know as is the only known network, or can I say the only known cloud provider that is actually doing this. So in my next picture, I will explain maybe to what degree why this is very interesting. And so by actually giving an illustration here. So in this map, you see the distribution of many dots. So each dot over here represents what you call a content distribution network. And the content distribution network is actually a means from which actually you can actually load content. You bring content and even bring data much closer to where it's needed or where the eyeballs are. So as you can see, if you look a bit carefully around the Middle East, Cloudflare has many content distribution networks in such places as Saudi Arabia, Kuwait, Bahrain, Qatar, and even Iraq they do have, and also Egypt and Turkey, to name just a few. So why would one consider perhaps maybe deploying a root server or at a large public cloud provider, for example? First of all, given that what you've seen in the map, Cloudflare is globally distributed. So if you wanted to provide a service that's globally reachable, then you'd maybe prefer actually hosting it at a large cloud provider. Secondly, cloud providers and CDNs in particular are optimized to deliver content as fast as possible where the eyeballs are. Thirdly, it is very efficient because round trip time is actually quite fast when you're closer to a CDN. Rather than maybe routing your traffic to Europe or to the United States, it's actually much closer at home. And of course, deploying also in a cloud provider, you do actually need to maybe make a good investment, because if you're going to actually have a globally distributed network, you're going to it'll maybe you'll need also some monetary commitments on that. So given this third method, ICANN is still looking, and it's actually doing some research on whether actually it makes sense to deploy maybe instances in a large cloud provider. So now I'm going to give a very interesting scenario, and maybe this is for food of thought for those who are network operators and you have millions of customers in that you're serving. So one of the things that you have to consider as maybe an operator, network operator, is that when you're serving millions of customers, you do have to give them the best quality of service. You don't want maybe any latency or delays in maybe how or in maybe mobile calls or even in data. So in this case here, you have to take a great interest in your DNS infrastructure. So I'm putting myself in your shoes. If I'm a mobile operator, I'll actually invest in my DNS infrastructure and making sure that it is actually available and it provides much needed services 24/7 at the most efficient, in a very efficient manner. I did put a note here that when you're using an iPhone, maybe not an Android device, and you're connected maybe to a LTE or 3G network, or you may find that basically it's hard if you try and change the recursive or maybe the DNS settings. That's because usually for the iPhone, they're usually stuck and they're fixed. So this brings me into perspective that given that you're actually giving your own IP address for your DNS resolver to your customers, you actually have to pay attention to maybe with the service delivery. And on this diagram, I'll just give you an example of just how the infrastructure is. So on the left-hand side, you have your customers. At the center, that's your recursive name server. That is your core infrastructure that is under your authority. This is the infrastructure that I feel attention should be paid to, especially given how critical it is. And this brings me now to Hyperlocal. Hyperlocal is a way in order to build now a more reliable service and a more reliable recursive resolver that actually helps in providing the root. So I've given three examples of how the root is actually deployed: by shipping a box, by actually putting it in in-house, and even the third one of putting it in a large cloud provider. But Hyperlocal allows you to actually deploy even the root zone or have access to it in your own infrastructure, in-house infrastructure. So this gives some very good advantages, especially if there's maybe, let's say, a DDoS attack, and I hope this doesn't happen, on the root server system, or the connectivity, perhaps maybe your internet connection to the outside world is being affected or degraded. Having maybe a copy of the root zone in your own infrastructure while all this is happening can be a very big advantage. So if you have a local copy of the root zone, you will never have to make calls to the root server system. And you could go straight to the TLD servers and you start the resolution process immediately. So as it turns out, some large resolvers, large recursive resolvers, especially in the United States and Europe, are already doing this. So they are actually running a root server locally on some machines, and on their recursive resolver, they are actually deploying what you call hyperlocal. So just to give only just a brief background, is that Hyperlocal was coined by one of the internet pioneers, Steve Crocker. Steve Crocker is actually did quite a lot of work in DNS, and he wrote the first RFC, which is actually an internet standard that is still used today. And RFCs are very, you can say they're the de facto laws of the internet, technical laws of the internet. So Hyperlocal has been used, but in various ways, and some deployments, basically they just got a copy of the root zone and they deployed it on their servers. But it was not until this year, June 2020, that it was actually standardized in a document known as RFC2020. And I can share with you the resource to this document. And my colleague Paul Hoffman was one of the co-authors, as well as Warren Kumari from Google. And for those of you who actually enjoy technical underpinnings and also descriptions, in brief, the document says that when you're deploying Hyperlocal, the root server has to be on the same machine. So in this case, as I showed in the previous diagram, it must only run on the local resolver. It should not be accessible to any public machine. It should run locally. At the same time, it can only answer queries from the local machine, and not to other machines. So in other words, only your customers for whom you've configured your recursive resolver settings can access that machine, and that machine will answer queries only to those customers and to no external ones. And it also recommends a failover solution. So a failover is, for example, maybe your machine is offline, so your resolver in your premise goes offline. So what does it do? The specification states that your resolver should then maybe contact perhaps the nearest root server system, if it's available within the region. So if, let's say, maybe Bahrain, and perhaps there's no mirror of the root, then perhaps the nearest one could be in the United Arab Emirates. So it will maybe contact that to just grab a copy of the current root zone. And so that's just a failover solution that happens if that the document describes. All right then, so you can actually run Hyperlocal. I will just mention that this is done by actually doing a zone transfer. So the zone transfer is done using those following domain names that are listed there. And some of the root server operators that I mentioned, some of the 13, at least 6 of them do allow actually zone transfers directly from them to your actual resolver, such as the B, the C, the D, the F, and the G and K. And another thing is that I'll just mention this. Some of the more DNS, can I say, software vendors are supporting this, such as Bind and let's say Unbound. There are also others I've not mentioned here, but I'm just giving an example that those two do actually support Hyperlocal in their configurations. And on the other hand, on our part as ICANN, we are do actually planning to on zone availability service. This is a project that's ongoing and perhaps it will be actually released in 2021. So that's part of what we're also doing. And also we're still testing and doing R&D and on Hyperlocal ourselves. And my presentation today is pretty short. I didn't want to make it very long. And if you want to engage with us at ICANN, you can actually reach us on our website.